Let's talk about how Earth was created, more accurately, how it formed, based on what modern astronomy and geology can test and observe. About 4.6 billion years ago, the solar system began as a large, cold cloud of gas and dust called a nebula. Something, possibly a nearby supernova shockwave or the gravity of passing stars, disturbed this cloud and caused parts of it to collapse inward. As it collapsed, it started spinning faster, flattening into a disk. At the center of that disk, gravity packed material so tightly that it heated up, eventually igniting nuclear fusion. That became our sun. Around the sun, the remaining material stayed in the rotating disk. Tiny grains of dust, ice, and rock. Inside this disk, small particles began sticking together through gentle collisions. Over time, these clumps grew from grains to pebbles, then to boulders, and eventually to kilometer-sized bodies called planetesimals. Gravity took over. Planetesimals pulled in more material and collided with each other, building larger bodies called protoplanets. Earth formed in the inner solar system, where it was too warm for light gases and most ices to remain stable. That meant the growing Earth was mostly rock and metal. Early Earth was not a calm planet, it was a violent construction zone. Countless impacts delivered energy and heat, and radioactive elements inside Earth also produced heat. The surface likely melted into a global or near-global ocean of magma. As Earth grew, it began to separate into layers. Heavy metals like iron and nickel sank toward the center, forming Earth's core. Lighter rock rose upward, forming the mantle and, later, the crust. This process is called differentiation, and it's one reason Earth has a magnetic field today. The moving liquid iron in the outer core helps generate it. One of the biggest moments in Earth's early history was the formation of the Moon. The leading explanation is the giant impact hypothesis. A Mars-sized body, sometimes called Theia, collided with the young Earth. Debris blasted into orbit, and that material eventually clumped together to form the Moon. Evidence comes from moon rocks that closely resemble Earth's mantle in composition. Next came Earth's early atmosphere and oceans. The first atmosphere was likely lost to space, but a new one formed as volcanoes released gases like water vapor, carbon dioxide, and nitrogen. As Earth cooled, water vapor condensed and fell as rain, filling basins and creating oceans. Some water may also have arrived via water-rich asteroids and early solar system material. Over hundreds of millions of years, Earth's surface continued to cool and harden. The crust formed and broke into moving plates, driving plate tectonics. This constant recycling of rock helped stabilize the climate over long time periods and set the stage for life. So, Earth wasn't created in a single event. It formed step by step. Dust became rocks, rocks became planetesimals, planetesimals became a planet, and a hot, molten world cooled into the layered, ocean-bearing Earth we know today.